Okay, there are several types, but two broad ones are the function decorators and the class decorators. So as the name already shows, or if you can hear the name decorator, that there is other than to decorate. So you decorate, so you make something more beautiful. Okay, so a decorator is a design pattern in Python that allows a user to add new functionality to an existing object without modifying its structure. So you don't modify its structure, but you just add some beauty, you add something, some functionality. Okay, so that the decorators are usually called before the definition of a function or the definition of a class you want to decorate. So which means you have the original function, or you have the initial class which is not beautified, and then you make it more beautiful by decorating it. Okay, or adding some salt or some sugar, also whichever you can say. Then in Python, decorators are essentially functions that take another function as an argument. So then you modify its behavior, and then you return the modified function. So in other words, the whole thing is that you make it more beautiful, or you make it more decorated, okay, by adding something that can be done to the original function before and after it has been executed. Okay, let us see in general, when you want to declare the decorator function. Okay, in this video we're going to deal with the function decorators, but you can as well have the class decorators. So that's where you can modify and beautify one class using another class. Okay, so the one which but in this one we're going to deal with only the functions. Before up to here, they will run before the function which is passed into this decorator has run. So this one will run first from 5 up to 9, and then after this, okay, after you run this one, okay, then what will happen is that in line 10, that's when now you will run the function. It will happen here. After that, then you pass over control to the function itself to run. So the function will run in the very same way how it is supposed to run without wrapping, without decoration. Then after that, after the function has run the way it runs, then the wrapper continues. Why do we do this? We do this, it's not a must that you should have before and after, but there will be some functions which need to be decorated before it runs, and there will be others which need to be decorated after it has run in line 10. But there will be others which will need to be decorated before and decorated after. So these ones are like placeholder statements, which means if you don't want anything else after the function, then you can just ignore this part. If you don't want anything else before the function runs, then you can ignore all this point in the wrapper. Okay, but now if you ignore this one at the top and ignore this at the bottom, then it's like making it beauty will do nothing. So it means it will remain the very same it is. So which means that whichever the case, it means at least you have some statements before or after. Okay, yeah, even if you have both, it's fine. Yeah, you can have both before statements and after statements, as many. And then after now, you have done the after statements, all these ones up to here. Okay, then up to here, then now you see then. Okay, it's still continuing, so I can remove here again. Okay, like that. Yeah, so all this is after. Yeah, so because I want it to look logical. Okay, yeah, so if you are following this one, we're just importing the time, but this one maybe I can put a space. Okay, so our function is starting from here, from 4. So this one we already explained, and then this one, the wrapper inside, we indent there. This one now we pass control as we explained. This is the before, and then after that, in line 10 now we've shifted to 7 by 11. That's the actual function will run, and then we keep on decorating after the function has run with these statements here. Yeah. So then after that, then we close the wrapper. So this we must return the wrapper. Always must return. If we don't return the wrapper, then there will be an error. Okay. But this one, the function which we have inside here. This one which we have here, if we want, we can return something inside here. If we want, after doing this, we can return something, but if not, we can just have those results comprehended somewhere like here. So you can return result, or you can just put them there, it doesn't matter. But this return of the wrapper is mandatory. It must be there before we have the time, and we run the function, the actual function, and how long it has taken. Then we have recorded the time difference, so to 60 process in seconds, because it will be fast. And then of course, if it goes into minutes, they need to show so many seconds. Okay, maybe to show 150 seconds if it was running more than a minute. Okay, and then return the wrapper. Okay, so let me run. So if you run, you have declared this function. It will not give any result so far because you have just defined the decorator function. Okay, then next is now to have the actual function now, which will go inside here on 11 here, because here we're talking about a function, the function which is func, which is here, which is passed there. Okay, so we'll put the function. Of course, you could use any other name here. We'll just put function. You could put anything here. We'll just put maybe only f here, then it means here also we just put only f. Okay, then it means if that was the case, it means even here, wherever there's func, you just put f. Okay, then now if we come here, like a greeting void function. What does it mean by void function? A void function is the one which does not return any computation, no nothing else. It's not so that is the void one. Okay, so like this one, it's just printing. Of course, it's not returning. So what we'll do here is you just say define the greeting function name, which is greets, and then you put the name of the person you are greeting. Then this one, it will just do these statements, which is not returning, but it will just print hello name. So if you said you passed in the argument here, the parameter maybe John, then it will say hello John, and then here it will say this was a greeting for John, or we can put a special greeting. This was a special greeting for John. See? Okay, full stop. See, and then how would that be called? This is the function from here up to this is the function. So what happens? This is the function. Okay, the original function which we said, which here we are calling and you see this is the other function, the original function, which needs to be beautified, to be passed here in the decorator, timing decorator. Okay, so which means what we do is just before this function we put with the address here. It means this. It means that one which we had here, the locator function, the timing logging function. For the computer for the interpreter to know that this one is a decorator, we start with the address character, the ampersand. So if we put the at not ampersand, the at address, if we put the address, this one character, then what timing log this one, then it will know that this is addressed as the decorator, and then it means immediately if the function that follows below will be decorated by this one. When you call this function now here, what it means is that when you say greeting Peter, because you have got this timing decorated at top there, logging, then when you say greeting Peter, it will not just run greeting Peter. Okay, if there is no this one on top here, okay, let me do deliberately. Let me comment here. So let me comment here. Okay, comment is like hash like that. It means comment, which means if you put like that, it means so you see this one timing logging, this one is not allowed annotation values equal parameter title markdown. See, okay, so I can just leave it directly like that deliberately. It means it will, if I run, you see that it will run just hello Peter, because here we have said if you see what we've done here. Okay, so okay, this one, okay, let me remove here, okay, like that, so that you see. Okay, so what has happened is that we have just run this one, because I commented this line too, so I've just run that one which as it is without decoration, you see. But now what about if I run now with a true there, the way it is now? So it will not just run this function greeting Peter, but before it does this, it will have to follow now what this decorator. Okay, the time logging. Let me run now. You see that now what it will do is it will follow what we are doing there. We printed a line, then do all statements before the greeting. You see, it was put greeting function is called here, and if you can see that it has, yeah, so you can see here that we have, okay, I've made it, I've zoomed it so that it's big. Okay, all right, so maybe it's too big, let me make it smaller. Okay, so if we see here, not self, but let me, yeah, so if you see here, you see that you have calling the function greeting, and then hello Peter, so which means it did this before the function. If you had so many things you would do there, okay, but now it's calling the function here, then it did now the way the function was, which was this. Okay, so it calculated the time how it took to do this, and then it continued with the what the wrapping function. You do all these ones after doing the function. See? So then after that, then the function, you say the function greeting returned none. You see why? Because this one was a void function. So if it's a void function, it returns none by default. So which means where this value here, where we said the return, this one, let me go here where we said here, we say the function greeting returned result, which means if it's void, it will be none there. See? Okay, so here we entered a new line, and then we'll go to this one, and then we have this one, entered a new line. But before that, I wanted somewhere a new line also here. Print this one, it has done, and then a new line. So I can put a new line here before. Let us just put a new line here. So I can put a new line there. Okay, based on what I'm seeing down here, because what I want is after it has run this one up to here, I want it to start with a new line here. Okay, and then it has that, and then after greeting the seconds, no new line here. So after saying seconds, let us remove the new line. After seconds, where is it? Here. Let us remove this new line because I've reordered these things. Okay, so let me run this one at the top so that I change it. Then if I run now this one, this one now, you see now that what I've done is I've changed it so that it looks like this. Yeah, so that these ones are the statements you do before, and then you call the function, and then it prints and it locks the time that you have completed this function, and then you do statements after, and then including what now reporting the function greeting returned this one, and this function it took what the greeting function executed in this seconds, and it returned this one. Okay, so you can see this is the explanation of exactly what I was explaining. Okay, so which means you have the my decorator function. This is the decorator function. It takes another function as an argument. The wrapper has got the arguments and the keyword inside the decorator. We define an inner function which we call the wrapper, and this function will be the one that actually replaces the original function, and then it accepts arbitrary positional arguments. These are arbitrary ones, okay, where there's no ordering of like keywords or like that, but and keyword arguments. Keyword are the ones which are like dictionary or key value pairs, and then which means the position matters. So which means these ones, they are arbitrary position. The position does not matter. You can put it anywhere. Whereby the keyword, these ones, they are called by the position, because you have a specific position for in the dictionary allocation with a pair of key and value. Okay, so which is ordered. Okay, so to ensure it can wrap any function signature, which means to make it beautiful. So the adding functionality. So inside the wrapper, we can have some print statements and the like before we call the what original function. This is where you would inject your custom logic. You can do so many things, and then e.g. logging, timing, authentication, passwords, whatever, math factor, authorization, that's MFA, authentication, or maybe two-factor authentication, 2FA, or whatever. All these things you can be doing here. Okay, and then results. So the function argument, this one, the original function is called the argument and it returns the results. Okay, yeah, examples. So for this one, the add two numbers. So which means for math, import pi, and then at timing, logging this one, we call the logging decorator. Then def add this one, which means this is the function which is adding x and y, and then we decorate, so to follow that format that we decorated above, and then add. If we call add 4 pi, it means it will do 4 pi, but it will follow what we've been adding above. So let us see, you see, so it will do the same thing always. It will put a line on top there, and then it will put a line at the bottom, and then it will do all statements before, and then now here it has said add. The name of the function is add now, and then calling the function add, and then here the add function executed in 1 second. This is also 1 second, and then the function add returned this value. So which means when we added pi is 3.14, so 3 point something. Okay, so 3.142, and then plus 4, that will be 7.142, 1415, like that. See, and then it added, but this one before it took about this 1 second, and that one. Okay, let us do another example. That's adding two numbers but with a sleep delay. Okay, because this one I've already done this one, but with a sleep delay. So which means we're adding okay, but with a stray. Okay, so let me clear this one because I learned sometime. So I can clear so that we got nothing else. Let me clear all of them. So which means clear the output, and then let us clear also the output here. Clear the output, and then also let us clear this output. Clear the output. Okay, that's the end. Let us just run these ones quickly. So this one here, with a delay, it means we got the function delayed. It's up to here. Okay, then we'll call it at the bottom. So which means the function, this is the original function which will run add 4 5. But before we run all 5, inside you can simulate some work. You can do some work inside. For example, you can just say repeat. Let us repeat forward 3 4 this 1 seconds. Seconds. So here at time seconds, I can just put say counts. Okay, so which means what will happen is that it will sleep for this. So if it was doing for 1 second, then it means it will be 4 point something. If we did 0.1 second, it will be 3.8, like that. Okay, because it will have delayed for 3.7 seconds before it does that one. Let us run. So it will add, you see it is delaying, okay, by 3 seconds. Okay, so you can see that now it is the delayed add, which has taken 3.71 seconds, which means because we delayed by 3.7 seconds, then 714, so it means 8, it means it has taken 0.00 something seconds, but it was delayed by those ones. Yeah, that's why the difference is after 714.8, then here 714.99. So you see the actual what it performed was the difference between this one and this one, because there was a delay. Okay, and then but when it added 4 and 5, it returned what 9, and the name here is a delayed what add. So you see the decorator is beautifying this, the timing logging. If you do the modulus, you run this modulus of 19.4, which means you divide 19 divided by 4, integral division, and then it's what it's 4 times, which is 16. The remainder, integral remainder is 3, so the answer will be 3. You see, but it will be decorated by that one. If we run this one just on its own, if we run the selection, then it will just give the answer. Oh, but it did not print, so I want it to print. Now undo. I want to print. I want it to execute, to show, run the selection. Okay, so it will just give 3. But if you run the whole of it, the whole chunk with the timing logging decorator, then it will beautify this function. So you see it beautifies by that. That's the role of the function decorator. So do this one. That's the modulus, and then what mod, and then this one is what took in 3 seconds. Good. Yeah, so I think this way the time difference, so in the same way this one's time difference, then it will answer 60. If we just run up to here, run the selection, I find that it will just give say subtracting b from a, which will be 40 from 100, which is a is 140, and the result is what to give the result, which is 60. But if you run the whole of it, just run the whole output, then it will beautify this. So what we have run, but they will be wrapped inside. It will beautify by the line on top and the line at the bottom, and then do all statements before this one. So that's the subtraction, and then all this function that we had there, and then it will give the result here that was 60, and it took 3 seconds. Okay, finally the last one. If we go this one, if we see if we can just run from here up to, okay, from here up to, this is a long function. It's an example of a long function. Why long function? Because here you can see there is a 4i in range, and it means total I. This one means whatever is on the right hand side, you add to total. So total is starting with a 0, and then now I becomes in range. I will start from the 0. So 0 square will be 0. This is squaring, it's not multiplication. If we do like that, it's multiplication. I times 2, doubling. But if we put the 2 exponent, yeah, like in starter or in R, we use the caret. So like that, that is the square. But in R, it will not. This one does not work. So you use 2 like that. That's exponentiation. While double statistic. If you put one or single, it is multiplication. Double is power 2. And then this is borrowed from the C++. Okay, so which means what it means here, it's just the same as total. This one is exactly the same as, if I would write here, it's the same as total equals total. It's like that. So you could just write like that. So what it means is so here we did it a plus, so it must have a plus. Okay, I can put the spaces or not, it does not matter. Okay, so this one is exactly the same as what is on the left hand side here. What it means is what was total previous one, it was 0. So this is a for loop from up to return here. It means it will repeat this loop in the range up to n. If n, like I said, 10, then it will start with 0, then it will put I 0 square, which is 0, then it will add to 0, then total will be 0. Then I will increment I plus plus. That's why this comes from C plus plus. It will become now 1. Then 1 square, 1 times 1 square will be 1. 1 plus 0, 1. So the total will be 1. So in other words, total will be keeping square numbers. See? Total will be keeping square numbers. But not just keeping square numbers, it will be keeping square numbers, and it will be adding. So this is like, in other words, it's a sum square. Okay. What it means here is, this is another way of writing a function for sum square. Okay, so which means we have the numbers from 0 up to, if you put 10, it does not include 10. So it means we have the numbers from 0 up to 9, square all of them, and then add up. That's what this is doing. Okay, it's a sum square. Alright, so let me do it the way it was originally. So now by this one, it means you start from 0, 1, 2, 3, up to what? Up to 9, 9, 9, 9, 9, 9, 9, 8, because it will not include this one, the whole this number. If we put here, 9, range 9, so which means the range 9, it will stop at 8. Okay, let me run this one so that you see. Let me put a small one so that first you see, like 3, if it's one that we know. This means 0 square, 1 square, and 2 square. So 0 square, okay, let me start with let me put 4. 0 square is 0, 1 square is 1, 2 square is 4, so 1 plus 4, 5. 3 square is 9, 9 plus 5, 14. Then it will not include 4 square, so it's 14. So if we can run, but here it must be n, and then we run here 4. So answer will be 14. Let us run from here. So if we run, but we run only this cell, only this selection. Okay, I can just right click here. So run the selection. Okay, see, so to be 14 exactly. Great. We see that we'll have 14 here. But yeah, now let me take it back to this number. Alright, so this number, it means it will be very big, and it will add all the numbers and square, which will be too much. That's why here we'll have taking long. So let me run. That's why we're going to a long function. You see, you can see it is just learning 5 seconds. You see, so it has taken how long? It has added some squares. It has taken 5 milliseconds. Yeah, because it was added all the sum of squares, but up to 99998. So the sum is what? Sum of these squares is this number, billion, trillion, what quadrant, is too big. See, so this is a number long. Yeah. So this is the idea of beautifying, decorating with what? Function decorators. Yeah. So for today we'll stop here. That's what happens with the decoration function decorators. Okay. In another video I'll talk about class decorator.